Hey guys, this video will be going over how many solutions does an equation have. So to start on this very first slide is a review from last week, and this is solving for x when you have an x on both sides of your equal sign. So remember, this is the box method, or if you want to do it the other way, that's called the inverse operations. That is also fine. You're going to draw a big box, cut it in half, cut the top in half again, and then do the same thing on the other side of your equal sign. So draw a big box, cut it in half again. Remember that your x's are going to go on your left-hand side. Your numbers are going to go on your right-hand side. All right, so we see that 2x is already on the correct side, so that's going to just drop straight down. -1 is already on the correct side, so that's going to drop down. Remember, the sign that's in front of it has to stay with it, so that negative has to go with it. Now we're going to look at the two that cross over. So 4x crosses over, so it must change signs. So it starts positive, so I'm going to put -4x in the box. And then -5 crosses over and becomes +5. So far we have filled in those top 4 boxes. 2 of them just drop down. The other 2 that cross the equal sign must change signs. Now we're going to add the 2 little boxes together to get the big box. So 2 plus -4 is -2x. 5 plus -1 is 4. And now my final step is always the same. I'm going to divide by the number in front of my variable. I'm going to do the same thing to the other side. So on the left, the -2's go away. I get x equals, and on the right, 4 divided by -2 equals -2. That is my answer. X equals -2. Notice that this has just one solution. That is the only number that I can plug in for x here so that those two sides of the equation equal each other. So on slide 2, you will see our 3 options. We just did one that was one solution, and that's going to happen probably 90% of the time. But there are special cases where you have no solution or infinitely many. Our goal is to be able to recognize which of these 3 cases is happening. And there's a really easy way, once you have a simplified equation, to be able to tell. So for one solution, the way I can tell that it's definitely going to be one solution is that there's different numbers in front of the variable. So for instance, I have a 2x on the left, I have a 5x on the right. Those are different, so I know it's one solution. Going back to that example we just did, I have a 2x on the left, I have a 4x on the right. Those are different x's, so I knew I could solve it and find my x. All right, so when it's one solution, you will see different numbers in front of x. For no solution, you will notice that you have the same number in front of x. So I have a 3x on the left, I have a 3x on the right. However, the numbers at the back are different. So I have a +1 versus a -5. All right, so I know those 3 x's will always equal each other. No matter what I plug in for x, those 2 things will be equal. But I can never get +1 and -5 to be equal. There is no value for x that I can plug in to make those 2 sides of the equation equal. So there does not exist in a solution. So our answer is no solution. And then finally, our last option is infinitely many. Infinite means it goes on and on and on forever. So infinitely many solutions is anything works. Anything can be plugged in for x and both sides will be equal. So I notice that the x's are the same, so 5x, 5x, and my numbers are the same. So I have +2, +2. Both sides are identical. Both sides are the exact same. So that means I have infinitely many solutions. All right, so those are your 3 options: one solution, no solution, and infinitely many. All right, so on slide 3 here, we have some examples. At the top, you see our key. Our key tells us the number of solutions and what we should be looking for. So starting with the first example, I always start with my x's. So I see I have a 2x on the left, I have a 2x on the right. So far, my x's are the same. All right, so I know it's not going to be one solution because that means different x's. So x's are the same. Let's keep moving on and see what our numbers are doing. I have a -3 and a +5. Those are different. So I want to figure out what is my answer when I have the same x but different numbers. I see on my key here, that means no solution. So my answer is no solution, and that just means there is no value for x that I can plug in to make those two things equal. All right, let's go to our next one. Once again, starting with my x's. I have a -3x. I have a +4x. I can stop right there. They are different. I have -3 and 4. Different x's means one solution. All right, so for this assignment, you do not need to solve it. You don't have to solve for x. But if you wanted to, remember that that's just the box method. All right, and then our third example here, same thing. Let's go ahead and start with our x's. So I see a 4x on the left, a 4x on the right. I am going to move on to the numbers. So I see a +3 on the left, +3 on the right. Both sides are identical. Notice that the order has switched around a little bit, but both of those sides are the exact same. So that means my answer is going to be infinitely many solutions. It doesn't matter what I plug in for x, it can be anything. X can equal 1, x can equal pi, x can equal -17, x can equal 23 halves. Doesn't matter. Whatever you plug in for x, these two sides will be equal. All right? So what I want you to notice is with all these problems, it's looked like this, right? You have an x and a number on the left, you have your equal sign, and then you have an x and your number on your right. All right. If you move to slide 4, notice that they've gotten a lot more complicated. I cannot use that key until I have it in this form. X and a number equals x and a number. So on slide 4, I'm going to put a wall up at my equal sign, and I'm going to simplify both sides by themselves. So simplify the left-hand side all the way, simplify the right-hand side all the way, and then use the key to figure out how many solutions. So with example 4, I see parentheses. That means I need to do the distributive property. So I'm going to take the number in front and multiply it by both terms in the parentheses. So 4 times 3x is 12x. 4 times -1 is -4. All right, so notice that my left-hand side is now simplified. I've got an x and I've got a number. All right, let's do the same thing on the right-hand side. Once again, I see parentheses. I'm going to distribute. So 6 times 2x is 12x. 6 times 1 is +6. All right, same thing. My right-hand side is now simplified. Once I've gotten it simplified, now I can use my key. So let's look at our x's. I've got the same x on both sides. So 12x and 12x. All right, so I know it's not going to be one solution. Let's keep going. Look at the numbers. I've got -4 on the left and +6 on the right. So my answer, I'm going to look for where it says that it has the same x's but different numbers. In my key, I see it's that middle option, no solution. All right, let's do example 5. Same thing, right? It's big, long, complicated. I'm going to have to simplify before I use that key. So if I look at the left-hand side, remember, do the two sides separately. I see parentheses again. So same thing I just did, I'm going to be distributing. So 3 times 2x is 6x. 3 times -5 is -15. All right, my left-hand side is simplified. I've got an x and I've got a number. On the right-hand side, notice that I do not see parentheses. There are no parentheses. So that means instead, I'm going to have to be combining like terms. So remember, you're going to put your x's together, you're going to put your numbers together. So on the right, I say I have an 8x and I have a -2x. So I'm going to do 8 minus 2, which is 6x. And then the -15, it doesn't have anything to combine with, right? It's the only term left over here, so it's just going to drop down. All right, now my right-hand side is also simplified. So looking at my two sides, I see a 6x and a 6x. I see a -15, -15. Both sides are the exact same. They're both identical. So that means my answer is that there are infinitely many solutions. All right, so the main thing to know is that with all these problems, you must simplify before you use that key. All right, so you're going to be distributing and combining like terms. All right, so the first 4 slides here are examples. The rest of this Jamboard, you have 10 practice problems on your own. What I want to do quickly, though, is let's go over number 3. So on slide 6, I also want to go over number 3, and then you'll be able to finish the rest yourself. All right, so put a wall up at the equal sign. First thing you always do is your parentheses. So for number 3, this -2 is going to be distributed. So -2 times 3 is -6x. -2 times 1 is -2. I have not touched the 4x, right? The 4x is just hanging out there. So that's just going to drop down, right? It hasn't done anything yet. So just drop the 4x down. Notice I'm still not done, right? I still have 3 terms on the left. So now that I've done that, I don't see parentheses, so I can't be multiplying anymore. So I'm going to look to combine like terms. So I see I have 2 x terms. I have 4x, -6x. So 4 minus 6 is -2x. The -2 here doesn't have anything to combine with. It just drops down. Now my left-hand side is all done. All right, I have an x and I have a number. That's it. On the right-hand side, I don't see parentheses, so there's nothing to multiply. So that means I'm gonna have to look to combine like terms. So once again, I only see one number, but I see 2 x's, 2 variables. So let's combine those together. So 5 minus 7. So remember, the sign that's in front stays with it. So 5 minus 7 is equal to -2x. Once again, this -2 doesn't have anything to combine with, so it just drops down. Now my 2 sides are simplified. So I'm going to compare these 2 sides. -2x minus 2, -2x minus 2. Both of those are the exact same. They are identical. So my final answer here is that it's infinitely many solutions. All right, so on many of these problems, you will have to do multiple steps to simplify. So you might have to distribute and combine like terms. All right, so remember, do each side by itself independently, and then you can look at the key to figure out how many solutions it is. Your only 3 options are 1 solution, no solution, and infinitely many.